Hello viewers, Electric Circuits question 5, and how many more 10 ohm resistors do we have at our disposal? So we've added yet another 10 ohm resistor to the circuit that we had in question 4. The remainder of the circuit is the same, and we need to work out our total resistance. We'll do this a slightly different way for this video. We have 4 identical resistors. They all have the same resistance and they are connected in a purely parallel circuit, which means that the total resistance would be the resistance of any one of those resistors divided by the amount of resistors there are. We can do it that way if you've got a circuit which is purely parallel, made up of identical resistors. So we get 2.5 ohms as the total resistance. And from that we can get the ICOM, the common current, i.e. the current through the battery, which is by Ohm's law V over R. V is 24 volts and R, total resistance, we've just found to be 2.5, and from that we get an answer of 9.6 amps. Now let's look at for any 10 ohm resistor. So for one of the resistors, could be any one of them because they are identical. I equals V over R, which is going to be 24 divided by each individual resistor is 10 ohms, giving you 2.4 amps. Okay, so there's 9.6 amps through here, splits off to 2.4 going through this first resistor, 7.2 going through this wire, which breaks up into 2.4 through the second resistor, 4.8 through this wire, which splits here into 2.4 and 2.4, and then they join back up again at these junctions. So we've got the current through the battery and each resistor. We need to find the power output of the battery. So power of the battery is going to be I times V. Current is, we're dealing with the battery, which is the common part of the circuit, but we found that to be 9.6 amps multiplied by 2.4, and we get 230.4 watts is the power output of the battery. Now the power from each resistor is going to be I, which is 2.4 for each resistor, times 24 volts. So this is 24, not 2.4, that's the voltage, which is 57.6 watts. Okay, so each resistor uses 57.6 watts, and therefore the resistors in total use 4 times as many because there are 4 identical resistors, so 4 times 57.6, and calculating that you do indeed get 230.4 watts. So the power output of the battery is the same as the total consumed by the resistors, as we should expect. Thanks for watching. Over and out.